This is a triple presentation in order of appearance. Hi, I'm Ben. This is Kyle from Aerospace. This is Jacob from DeepSig. We are going to talk about SigMF version 1.0.0, and I'm going to open with eye candy that's just too cool not to show off immediately. So this is our new logo, by the way. That logo is a SigMF recording. So we've come a very long way from where we were. And Kyle is going to deep dive on exactly how that SigMF recording functions and what new features it uses. So before we go, I sort of missed getting to give the talk where I put tweets up on the screen about all the cool stuff that happened since Derek got to do that this year. So I picked this one. Daniel Estevez, right, creator and maintainer of GR satellites. Especially wanted to call it out since this is using SETI's Allen telescope array to track Voyager. And they've published, Daniel publishes the SigMF recordings of this, if anybody wants to go play with it, which is super, super cool. So to actually get right into what we want to talk about, we have officially tagged SigMF version 1.0.0 semantic versioning. You can clap. Yes, I heard that start. You can clap. Release candidate 1. I appreciate the golf clap. So this has been 4 years coming. We've closed a lot of issues and merged a lot of PRs from a lot of different places, and it's a pretty big deal. So the way that we went about this was the only previous formally tagged release was version 0.0.1, which from a semantic versioning perspective means that we could have done whatever we wanted. We could have totally blown away the spec and made something that was totally not backwards compatible with anything. But what happened is that it took us so long to figure out exactly what we wanted that version 0.0.1 ended up in super wide use, with lots of people using code, implementing their own libraries, and deploying systems using that version of the specification. So what we decided to do was effectively treat that as unbreakable. And so version 1.0.0 preserves backwards compatibility with everything that was in the previous release. We will not break backwards compatibility in the version 1.0.0 dev chain. Same deal as the rest of the radio branches. Moving ahead, anything that does break backwards compatibility will happen in version 2.x.x. And we've already got some ideas for what this might look like. And hopefully it doesn't take us 4 years to get there. But if you have ideas for things you've always wanted to see in SigMF but you don't think is possible today, come talk to us in our workshop. So that's the other part of this is that we have tagged the release candidate. It is live. Please go check it out. Give it a test run. Read through it, see if there's anything that you think is missing or is a gap for you. And then come talk to the three of us at the 2-hour-long workshop, I think, tomorrow afternoon. We have plenty of time to kind of walk through everything, how to use it, and get feedback and input. And if we need to tag another release candidate that includes your feedback, we're happy to do that. So another question. Up to this point, there has not been an upstream way to use SigMF. Everything was out-of-tree modules. Calling out, so especially SkySafe. So there was 2 implementations of GR SigMF. One very early that was written by a student who's now part of LibreSpace on a Google Summer of Code project in 2017, I think, actually. SkySafe's implementation of GR SigMF has kind of become the de facto standard. And that out-of-tree module is now going to be upstreamed into GNU Radio and will be officially an official part of GNU Radio's core distribution. Before that happens, it is going to migrate from its existing JSON parsing library to DeepSig's libSigMF. So DeepSig has invested a lot in building, it's not just JSON parsing, it's obviously includes a JSON parser, but specific to SigMF for GNU Radio applications. So both libSigMF will become a dependency within GNU Radio. GR SigMF will get upstreamed. Oh, and this is one more note. I know right now a lot of people are dealing with the fact that tags in GNU Radio do not look like tags in SigMF, and so you have to translate, right? If you have stream tags that are annotating something, you end up having to translate into SigMF when you record. We are working to align that in the future. That obviously is breaking, so that's not right. That's a breaking change that would not happen in mainline. So I'm going to cover 2 big changes and then hand it off to Kyle. One major item that's new is what we call collections. So there's now a 3rd file type in SigMF. It used to be just the dataset file and just the metadata file. There is now a collections file. Collections describe relationships between SigMF recordings. So for those of you who participated in like the 4-hour technical design discussions 2 years in a row about how do you reliably do multi-channel phased array recordings and maintain alignment between everything, this is how we do it. So we have a top-level collections file, and you can describe what each of the recordings mean within the context of all the others. The next one, geolocation support. So we previously had WGS80, it was also WGS84 based, but we kind of hacked geo support into the annotations part of SigMF. I think hacked is the right word. Oh, that is now deprecated. So we have adopted GeoJSON, which is widely used in other communities, and so it has lots and lots of tools that support it, which are very cool. It is also in line with general SigMF goals of using widespread successful standards from elsewhere. So this happens to be an IETF RC. Lastly, before I hand it off to Kyle, just a couple of quick other new features. SigMF within a single recording now supports an arbitrary number of interleaved channels. Right? So previously, you could have non-interleaved real samples or interleaved complex samples from one channel. You can now have interleaved samples from any number of channels within a single recording. We had the core label. The annotations field used to have just a description. The annotations objects used to have just a description field. And what we found was that everybody who was implementing viewers or SigMF applications effectively was overloading that field to make GUI visible information. And that was sort of silly. We should have provided for that in the spec. That's what the core label field is for. And finally, whereas you used to only be able to annotate things about your signal in time, you can now also annotate in frequency, which is pretty cool. So with that, I'm going to say the logo that you saw, that is now the SigMF example that we distribute within the core repository. And I'm going to hand it over to Kyle to walk through. Oh, I've covered the spec. In addition to the logo stuff, Kyle is going to walk through all of the code new features in the SigMF repository, right? The SigMF repository has both the spec as well as Python tooling.
Right, and then Jacob is going to actually show some cool visualization tools afterwards that are using SigMF files. Morning, everyone. I'm Kyle. Today I'm going to talk to you about sort of this issue that Ben posted. Hey, SigMF needs a logo. And I sort of thought about it for a while, and I made some lame, flat ones in Illustrator, and not a lot of excitement on the GitHub issue page after that. And then I was walking my dogs, watching TikTok, as one does, and
it's always just one single dot moving along a path. But as the frequency of the sound or the note you're hearing gets higher and higher, that dot starts to move so fast that it just blends together and looks like solid lines.
And I saw this and I said, well, if you guys don't understand what's happening here, basically there's a left channel and a right channel in the audio, and he's feeding it into an oscilloscope as like an XY plotter, essentially, right? And I saw this and I said, you know, I could probably do something like that for the logo. And I sort of excitedly ran back to my computer and I started looking into this. And I think I found the same software this guy actually used to create
it's always just
his thing. Now, this is a program called Oski Studio. Let me make sure that I get this in proper HD here, yes. And you're going to see some like iterations of the logo that I kind of created. Oh, shoot. This will work. And might be loud here for a second. But yeah, it's pretty cool. There's like a timeline for everything. If you have Blender, you can like actually have a Blender view go straight into the oscilloscope viewer. And if you have like simple geometry, essentially, you can like modulate it. This is the one that I posted, and Ben like posted some crazy emoji. He's like, "Oh my God, this is amazing!" And he was really excited. And then I thought this was going to be the one, but it sounds terrible, right? It sounds bad. And it's cool because you can like modulate different like effects and things over time. You can put stuff on a timeline. It's pretty cool. OSCI Studio. It's Windows only, which sucks, but other than that, it's a great program. Yeah, this one starts when I hit play. And I was kind of changing it around, and then I finally got to the final version. That's when I click on 5 here in a second. It's a pretty cool little program. Just one guy made it, basically, and you can, it's sort of a timeline for how you want to change your frequencies and modulations and your effects, and you can pretty much change everything on a timeline basis, like a synthesizer. And then I exported from this in 192 kilohertz and then reformatted it for SigMF, and we got something pretty cool. Now, just so people understand, I don't know if you guys have actually looked at like what a SigMF file looks like. You can have a SigMF archive, which is just a tarball. So if you ever see something that's just .sigmf, that's just a tarball that contains objects inside of it. So typically you'll just find like a SigMF-data, which contains like a binary object like you'd normally read in the olden days, where like you'd forget what the fields were and what your sample rate was and where you were when you took the actual data. And then there's the SigMF-meta, which contains this JSON. And then now you can also have the SigMF-collections object as well. And the annotations look like this, you know, author, credentials. It has a checksum for the actual file. When you're reading the file in SigMF, you can like optionally calculate a checksum or not. It does it by default. So if you have a many gigabyte file, you might want to skip checksum equals true. Yep. This is just, you know, this is what the spectrum of this thing looks like. This in there. I have like a sort of tool, not as neat as in Spectrum, obviously, but it just draws these little boxes and annotates the description field, but now I'll use the label field. There's a couple new actual binary things you can run. These are just like Python entry points, actually, but if you do pip install SigMF, you'll get SigMF_validate, and validate checks the file that you've created to make sure that like all the JSON is legit and everything works. And it also suggests things if there's, you know, if you've got like just a single line of JSON instead of like a nicely formatted JSON. There's a GUI, which I'll get to in a minute, but it helps you create the archive files. And it was submitted to the repo and we pulled it in pretty fast. It probably needs a little bit of work, but it does work. And one cool thing that it now does is it always exports the global field first whenever it writes the JSON, and then the captures field, and then any other fields are just alphabetized after that, which is nice because if you ever edit your thing in Vim, it's like all you want to know is like, what is this file, right? Core description. So here's an example of just like a random signal that we use in my company, you know, just with annotations on it. It's just nice to be able to have these kind of labels. So, actually, Ben, I was going to ask you, did you update the pip for SigMF? Okay, we will do that. We will do that today. I think if you do pip install SigMF right now, it does the version 001. But if you pull the GitHub, you'll get the version that we're all talking about right now. This is just the absolute minimum example. If someone hands you a SigMF file, either an archive or a full one, you can just do sigmf.sigmf.fromFile, blah, and then you get an object back. And then that object, you used to have to like specify an exact number of samples, but if you specify with no arguments now, it'll just give you the whole file. Also easy ways to get captures, annotations. And if you run the validation tool and it passes, it won't spit anything out. But if you run it with verbose, it'll say, hey, this is fine. If there's an error, it'll spit something out. This is what the GUI looks like. This is just a file I created for the CTF that I just loaded in here real fast. It allows you to add multiple, like show where the boundaries of captures are. I think that the presumption here is that you're starting with just a binary blob and you want to add SigMF metadata to it. We should probably make it a more generic editor. And from there, I'm going to hand it off to Jacob. Oh, we'll switch the computers?
Yeah,
Yeah, USB-C? No, okay.
just plain old HDMI.
You need audio?
No. Okay. So I'm Jacob. I'm with DeepSig, and I will show off a couple example applications of how one might use SigMF practically. Cannot see my screen. One moment. How about that? Yes.
Looks good.
So, yeah, one of the great visualization tools that our community has, courtesy of Mike Walters, is in Spectrum. And over the past year, definitely pandemic, SigMF, like a native SigMF support has been brought in, which is great because it allows you to do things that are really useful, like visualize annotated data. One of the really powerful things that SigMF provides you the ability to do is to highlight certain areas highlight certain areas of signals and time or frequency or both. And it's convenient, particularly within Spectrum, because if you load a SigMF file, it will automatically pull in the relevant information like the sample rate and the frequency, and you'll get the time values will just work. That it's very good. I will also show another example here in just a second about how you can build tools around SigMF for your purposes. So what DeepSig does is one of our products provides users the ability to label data for machine learning purposes. And I'll show just a very simple example of how that all works together. So here is in Spectrum, and I have some frequency hopping signal there, and with SigMF, it enables you to draw those annotation boundaries, so you can zoom in and look at individual signals in time and frequency and highlight them. In this particular example, it's a very nice data set, and it's not particularly interesting to look at. However, you can have much more complicated data. So here's some Starlink data, and you can start annotating the content of that with labels, so that when you're going back through and looking at your data, you have the ability to find data that is annotated and view it. Here is some more realistic data from the ISM band that I'd captured when I was developing some of the burst detection algorithms in GNU Radio. And this is where it becomes especially useful to be able to visualize this. There's a lot going on here. And if we just zoom out a little bit, you can see that there are a whole lot of annotations here, and they're visualized in different signal classes for reasons that I care about. And so it makes it immediately apparent what's going on, and lets you view that very conveniently. If you build the latest version of Spectrum, you will get SigMF support out of the box, which is fantastic. The other side of this is this is a tool called OmniSig that DeepSig builds and develops. If you're here live, you can come by our booth, and I'll show you this in more detail. But in this case, I have a recording of an OcuSync drone's video downlink. And one of the nice things, so this is the corresponding SigMF meta file. And one of the nice things is if I draw if I annotate one of these signals and save that, when I come back over here, you get an annotation, and you can do this for whatever reasons you have. Some of the fields that are in this SigMF metadata file are not in any of the public extensions because we have built tools for our needs. And SigMF gives you great ability to extend the specification within within reasonable parameters that the spec makes very clear. You can extend the data fields for whatever you need. Tomorrow at the workshop, we'll talk a little bit more about that. And if you think that that's something you might need, we can, be available to discuss if your requirements should be integrated into the core spec or into a canonical extension, of which there are a handful, or if you want to build your own. Let's see. Yeah, that was all I had to show off. Spectrum is free to download. Go get it if you don't use it. It's a great visualization tool for static data. Looking through, and use SigMF.
Thank you.
I have a question. Where do you get in Spectrum from? Is that just GitHub?
Yes, it's available on Mike Walters' GitHub. I think you may be able to get it through PyBombs also, if that's your lean.
Is Maitland, are you in here? Mate, yeah, is InSpectrum packaged? Okay, so you can sudo apt-get install InSpectrum. Okay.
Cool.
Awesome. One note on that, if you do choose to build it yourself, you need to pull in libSigMF, or InSpectrum will just build happily without SigMF support, and you'll wonder why you're not getting those nice boxes.
All right, thank you. Thanks, everybody.